We are all aware of the huge contribution of carbon dioxide emissions to climate change. According to the International Energy Agency, there's currently a yearly gap of nearly 800 million tons of carbon dioxide for reaching the 2030 net zero emission target. At the same time, each year, up to 1,000 million tons of carbon dioxide is also needed for replacing fossil-based carbon resources. Here in Finland, the forest industry generates roughly 20 million tons of carbon dioxide annually. And what if these emissions could be tackled by collecting the carbon dioxide already at the site of its generation, which could then be converted into a bio-based carbon feedstock? Drawing from previous fundamental research on the influence of fiber water uptake on gas adsorption, the CoFoam project aims to untap the potential of the inherent properties of natural materials to create moisture-responsive solid foam sorbents for water-assisted carbon dioxide capture. Nanocellulose-based structures have been demonstrated as promising carbon dioxide capturing materials, and CoFoam will further expand the raw material base from the forest-based resources to currently underutilized agricultural side streams, such as barley hemicellulose from beer brewing and nanochitin from food waste. We will utilize two strategies to further enhance the material's capturing performance. First, the selectivity for carbon dioxide binding will be increased through amine modification or incorporation of naturally amine-rich compounds. Secondly, the hygroscopicity will be exploited to boost the functionality of the materials and aid carbon dioxide capture. The use of bio-based low-cost materials is an asset of CoFoam, and the technology challenges existing solutions based on liquid amine scrubbing, suffering from energy intensity and low operational stability, and current solid sorbent membranes based on zeolites and metal organic frameworks, which are challenging to upscale and sensitive to water vapor present in exhaust streams. When successful, the CoFoam technology will not only reduce the carbon dioxide emissions from forest industry processes by at least 80%, but also significantly boost the value of cellulose-based products. In other words, the project contributes to generation of novel, bio-based, high-value products, as well as introduces a technology to respond to the demand for carbon and the set targets towards net zero emissions in pulp mills, biorefineries, and beyond. If you're interested to hear more, please follow us along this journey towards carbon neutrality with new added value materials. Thank you for your attention.